Good morning and welcome. We're going to be talking about the scoop on soil. What does that really mean? We kind of take soil for granted. Thankfully, our soil scientists do not. They're very serious about it. And we are learning, or they are learning and helping us to learn, that the soil is far more complex than we first thought. It may truly be the last frontier here on Earth. And this was said by a very famous individual, Franklin Delano Roosevelt, about the Dust Bowl and what was happening to our soils. A nation that destroys its soils destroys itself. This was the first time that we really paid a lot of attention to soil. And in that, at this point, we have a bit of a revolution coming. It's been here a while, but it's out there. Farmers are learning about it, and now we as gardeners need also to learn about it. So some of the resources that I used for this talk were the Master Gardener 10-minute university handouts. The top one here, Soil 101, is a very good one. It pulls together a lot of really good information for us. The others are also very good ones, Testing the Soil, because we're going to talk about that as well. The objectives for the class today are for you to become familiar with some terms that describe soil, to learn the 3 major soil textures, to learn how to determine your own soil's structure, and then to know what pH is and how soil pH affects plants and microbes. And I would like for you to come away with some understanding of how to protect soil structure. A lot of what's going on in soil right now is being done with farmers. Well, granted, they have a lot of soil out there that they're working and growing on, but we, as small farmers in our own little garden plots, need to know these things so that we can help the earth, help create healthy soil for our own plants. So this is the composition of what soil is. The one that always startles me when I look at it is to think that 25% of soil is air. Another 25% is water. And the things that we typically think make soil, the minerals, they're only 45%. And of course, then we think about organic matter, and it's a very small part. It includes organisms, roots, humus, and we need to know about all those and the other nutrients. Part of the reason the air and water takes up so much space is that it provides room for roots to breathe and grow. So let's look at the relative sizes of soil particles. In this case, sand is the largest. And of course, this is blown up so we can actually see it. There's a little white dot down at the bottom. A lot of times our sand isn't much bigger than that we have in our soil. It'll feel gritty. And if you've ever used sandpaper, that's what it's going to feel like in your hands. Silt is smooth. It fills in the little grooves on our fingerprints. And so it has a very smooth feel to it. Clay is very minuscule, but when grouped together and dry, it can become very hard. It can be molded, but when it's wet, it's very sticky. Clay is also where we're going to find the majority of our nutrients for our soil. The other, which is our sand and our silt, is basically comprised of very small rock particles. So here's a hands or ribbon test, which you can perform at home. And it's one of those that you can invite your grandchildren and children or neighbor kids to try. And you're basically going to get rid of all the soil on the top that has been amended with compost or mulch. You want to go down to your native mineral soil level. And that's true for any soil test that you're going to be doing. So you do that, you gather up a little bit of soil, you put it in your hand, you add some water to it, work it a little bit, and then you see if you can squeeze it out over your fingers into a ribbon. If the ribbon only goes an inch or so, that means 1 inch is equated to 10% clay. Now, these are very general. This is not a specific test. This is a more specific test, sedimentation. And I'm going to tell you what the supplies are, and then we'll do the test and I'll walk you through that because some of it is a little vague. When you look up soil sedimentation test, you will find information on a number of varieties. I tried to pick the one that I thought was easiest to understand and fairly complete. So for taking a sample, you're going to need a shovel because you may be clearing off 6 to 8 inches or maybe more to get down to that native mineral level in your native soil. A trowel, because down that far, it's going to be a little harder to scoop it out. And something to put it in. Can be a bag, doesn't matter. And you're going to remove any large twigs, rocks, clods you can break up. For the sample processing, you'll need a straight-sided jar, which you'll see in one of the next slides. You'll need some water, measuring cups, a 1 to 2 cup size, a spoon to kind of stir it up. You'll need some measuring spoons and some dishwashing machine soap. That's low sudsings because we're going to shake this jar up and you don't want to have a jar full of suds. This is a sedimentation test, and it gives you a pretty good idea of what a straight-sided jar ought to look like. And you're going to take that soil that you dug out of your native soil, and you're going to fill a jar 1/3 of the way with the dry soil. Any clumps, break them up. Then you're going to add a tablespoon of dry non-foaming dishwasher soap. And what that does is it'll make the layers as the sediment settles out more clear. The thing is, if you don't have it, that's fine, but it may take a little bit more time for it to settle nicely. So you can use a quart jar, you can use a pint jar, but the idea is the same. You're going to fill it about 1/3 of the way full. And the rest up to 1 inch below the lid will be water. Make sure you get that lid on tightly because you're going to be shaking this thing. And the last thing you want to do is spread mud all over the place. You're going to shake this, and here they don't really tell you how long, but of the other things that I read, it can be anywhere between 2 minutes and 5 minutes of shaking. Once you've done that, you have a jar that's going to look like this. You want to put it on a level surface. And in about 2 minutes, your sand will have settled out and you can see your sand layer. Silt is the next to settle out, and it takes, I'm going to say, about an hour. It depends on your soil and how thoroughly you have shaken it. Clay is the lightest, and it's going to settle out in about 24 hours. Now, it can take more than a day, and it can take up to 3 days total. Once it has settled, use a permanent marker to draw a line at the top of each of the levels of sand, silt, and clay. And then you're going to use a metric ruler to measure the depth of each layer. Here you'll notice that we'll start from the top. The clay layer is 0.6 millimeters, so you will need to make sure you have a metric ruler. The silt is 2 millimeters. The clay is 0.6 millimeters. That's our total of 3.6 millimeters. So once you've got all that, how do you take that and put it into a percentage so you can use your soil triangle? I want to point out something about the triangle first. Look at the left-hand side where it says percent clay. At the bottom left corner, it starts with 10% and it works up to 100% at the tip. On the right-hand side, we have silt, and it begins at the tip, working down from 10 to 100. The same thing is going to be true with the percent of sand. It's going to start out on the lower right-hand corner of the triangle and move left till it gets to the 100. So how do we figure out the percentage? We are going to take clay first at 0.6, and we are going to divide it by the total height of the layers, which was 3.6 millimeters. That comes out to 16.7. We do the same thing for the silt, which comes out at 55.55%, and the sand at 27.75%. You're going to take those percentages. We go back to the left-hand side, and we start down at the bottom. On the left-hand side, we come up to where we can gauge anyway. That would be 16.7. And we draw a line across the bottom of the triangle. Then we are going to go up to the percent of silt, which was 55.55, from the tip of the triangle down to where 55.5 or very close happens to be. The last one then is going to be the sand. And so you'll see a line drawn there between 20 and 30. These three lines should intersect. If they don't intersect, go back and try again. It probably means you got off in the wrong direction. So this soil comes out to be a silty loam. Loam is the perfect soil. The ones around here, around the center of loam, happen to be ones that are going to be good soil. The ones out further than that will probably need some help. So how does soil texture, now that we know it, how does that affect the garden? We are looking for a texture that is going to help hold water, that is going to provide some fertility, which remember is clay, and the permeability for water to go through the soil, and that happens to be sand. So loam is made up of almost equal portions of water holding capacity products. Let's see, that would be our clay. Well, clay holds, yes, you do need clay. Fertility is going to come from clay, permeability from sand, but it's a combination of the three in almost equal parts. So we ended up having a silty loam. A silty loam is going to be high in water capacity. It's going to be moderate with fertility, doesn't have a whole lot of clay in it, and it's going to be very permeable, which means the water can go through quickly. And that can be low to moderate, and that's depending on really how much sand there is through the whole thing. Here we have a nice diagram that shows how the three soil textures come together to make soil. So you have individual particles that aggregate to form what is known as a bed, or you can call it an aggregated clump, and they stack together. These are pretty dynamic, but the soil over here on the right shows them in a little truer form. So you've got some large chunks of soil. You've got little ribbons of something running through there, and you've got some things that are not white, but they look like they could be roots. So these beds group together to make soil. And in this case, the dynamic part comes in that they're reforming and deteriorating and reforming about every 4 weeks. too fast. So each of these little aggregates are held together by fungal hyphae. You saw the white crunchily little lines in the photograph. Most of that's going to be the fungal hyphae. Some of it could be roots. There's bacteria in there and a little bit of organic matter. The bacteria provide some of the clay. The hyphae are like having little ropes tying it together. And together it makes a bed. So here the sand is going to be a fairly large portion of the composition. That's the medium brown. We have clay that is a very dark, almost blackness there. We have the hyphae up in the upper left-hand corner that come down really kind of like ropes. And if you've seen roots, they can do the same thing. Silt is sort of a medium brown in there. The orangish red happens to be organic matter. And there's some little black specks in there that are going to represent bacteria. This is a close-up. I always think it would make a nice fabric print because it's got such lovely colors. I want you to look first at the large blue lines going through. That is water. That is water going through the whole system, and they need micropores in order for the water to drain well. Now, it's not going to drain all the way because you'll notice the snakes or ribbons there are much fatter at the top than at the bottom, because as the water filtrates through, it also goes into the micropores, which are the smaller clusters, also known as a PED, that show blue circles in them. Those blue circles are held in there because they're micropores, and the water will cling to the smaller pores in there and be retained for plants to take up later. When those fill up, the water continues on down into the rest of the soil. So macropores are really the large areas in there that you don't see anything. The micropores are the smaller areas around that drawing. So fungi and roots have mutually beneficial associations, and it really sounds kind of neat. The fungi get carbohydrates from the roots get water and nutrients from the fungi, making roots more drought tolerant, because remember we said the micropore ones that are going to store the water, and it also means that the roots can be more stable. So there are many kinds of fungi out there, some specific to certain plants. And that means you want to try to integrate several types of plants to make sure you get a broader spectrum of fungi. The picture on the left basically is showing a plant that sets nitrogen. So you see some little lumpy things in there amongst the roots. The roots themselves of plants are going to exude 5 to 20% of the carbons fixed by photosynthesis. A lot of that will stay in the roots. And if you don't think there are many microorganisms out there, quite frankly, there are a lot. A quarter teaspoon of soil is going to have about 1 billion microorganisms. The fungi, these are just some fun factoids about them. They are decomposers and recyclers of soil nutrients. It's kind of interesting because we make a big deal these days about recycling, and these guys have been doing it like forever. Forests would be littered with a great deal of wood if it were not for fungi. The bacteria and microbes by themselves are not sufficient to break down cellulose. However, the fungi can do that because they're after the carbohydrates. Fungi have no internal digestive systems. Everything is pulled up through their hyphae or roots. And those hyphae are going to go into the food, thus breaking down the cellulose in them and getting carbohydrates. So they have incentive for breaking things down. The fungi also releases minerals, sugar, and amino acids for the microbes. Microbes will take that and they also will make it available to the roots of different plants. And all of this is made available to other organisms that are in the soil, some of the smaller ones we can't really see. Through a lot of this, what we are going to want to emphasize is feeding the microbes in the soil because they end up feeding other things. So it's a very nice ecosystem under the soil. So why is soil important? Soil provides food and fuel and feed and fiber and medicine. It filters water and supports landscape plants, as well as homes and cities. So on the left here, and I want you to kind of think about this one because there are a lot of things that we don't think about as being and coming from soil. On the left is not only a landscape and enjoyable to the people who are there, but it is welcoming to wildlife. On the right, we're talking about adornment. And while beads of clay and particles of soil may not be the first thing that I think of a lot of the native peoples around the globe who used soil that had minerals in it of different colors to paint their skin. And we still do that today. We're back now to talking a little bit about pH, but here's our healthy soil photo. Basically, pH is the key to healthy soil. The scale on the next page shows how we identify acidic soil, which is at 0 and very acidic, just like battery acid, which will burn your skin off, to how alkaline the soil is at a high of 14. So the scale goes 0 to 14, 14 being much like bleach. And you know what that feels like if you get it on your hands. And if you don't, try a little drop and see what it feels like. 7 is the neutral, and that is going to be your pure water. So here's the scale, and we're going to jump around just a little bit. I am going to read a little bit about the main ribbon there. On the left, it says acidic. Well, how does our soil get acidic? It depends on where your granulars of rock for your sand and silt are coming from. It also depends on how much rainwater or irrigation water you are running. So you go down to vinegar, red, and then we have rhododendrons and blueberries, and we'll talk a little bit more about those. Vegetable plants, we get to the other end, there's our bleach and our sodium hydroxide. I want you to look at the banner across the top. It says most plants grow in the range of a 4.5 to a 9.0 pH. So the middle there is a little bit more conducive to growing vegetation. And most vegetables, bringing this in a little closer, happens to be between 6.0 and 7.5. Now that's most. You have a few that go outside that. Tomatoes are at 6.0 to 6.8, and carrots seem to like the same thing. On the left there, just scooched aside, were the rhododendrons and the blueberries. And I want to mention them because we all know they need a more acidic soil. To show you how effective rain can be at acidifying the soil, when I lived in Juneau, Alaska, we had a friend who had landscaped beautifully with some lovely rhododendrons. Well, as it turns out, the rhododendrons were looking sick. He checked with the extension agent, who suggested a pH soil test. He did the soil test, and his rhododendrons, which are pretty happy in a fairly acidic soil, needed some lime to bring up the alkalinity of the soil and reduced the acidic part. After he applied the lime, his rhododendrons were again quite beautiful. Now, at the bottom there, it has information about the range that most soils are. They go from a 4 to a 10. But with the case of these rhododendrons in Juneau, Alaska, we had 97 inches of precipitation annually, and they did a very effective job over a few years of washing away the things that would have made it less acidic. So all was left was the acid. Also, I want you to know that the numbers here, we don't just have 14 numbers. No, between each one of those numbers, 5 and 6, is a 10-fold difference in the acidity. So a 6 is 10 times more acidic than a pH of 7. And I was wondering what pH stood for, so I looked it up, and it basically indicates the amount of hydrogen per liter of solution. So what does pH happen to do? Well, if it's too low or too high, like with those poor rhododendron, the pH was too low, and it can cause poor plant development, poor plant growth, and just sickly looking plants. And on the left, I wanted you to see that we have some really nice looking white winter wheat there at 5.6 pH. And then we have some bald and patchy areas. There's not that much difference, you would think, between the 5.6 and the 5.2, and really can there be much difference between 5.2 and 5.0? In this case, there's quite a bit. This soil has virtually nothing growing at the pH that's 5.0 and below. The garden on the right, there's a clue that this is a pretty healthy soil and that the pH is probably somewhere between the 6 and 7.5. And that is going to be the range where you're going to see the best growth on your plants. Part of what pH does is it can confine the other elements and nutrients out there and keep them from being taken up by any of the plants. Some plants have very specific ranges for their pH. So how can we improve the soil? This is one of the things that's in the revolution, that we want to feed those microbes. We want to improve our soil. And I'm mentioning mostly cover crops because they slowly feed the nutrients back into the soil for the microbes and fungi. So while most soils can benefit from an addition of organic matter through cover crops, which are green manure, or adding compost, you do need to be careful if you are adding compost all the time. So for established gardens, it's recommended about a ½ inch of compost a year. If you go with a green manure, you don't really have to worry about this because it's only got low levels, which are sort of divvied up as you go along. For a new garden, you're going to want to add probably 1 to 3 inches of organic matter. The organic matter here, in our purposes, means material of biological origin. And I want to point out how clumpy the soil is on this particular cover crop's roots. Now, we don't want to go around pulling up things, but this is a really good illustration. So what does adding compost really do? Well, for us in this location, we really can't tell easily that we are adding stuff because frequently the compost that we have is as dark as the damp soil that we have for most of the year. So I did this test with sand. I didn't know until I was in my 60s that it is also called sugar sand. What I did know is if when you went out to dig If you wanted a hole 8 inches deep by about 8 inches around, you would be taking out 3 shovelfuls of the sand because it fills in the hole almost as soon as you can get it out. So this is extremely sandy soil. This is 1 bag, the 3 cubic foot of steer manure compost, and it covered an area 3 feet by 1. Once it was turned in, you can see that it did enrich the soil. It also increased the water holding capacity of that soil, which is real important when you've got very sandy soil like this. So here are some soil health principles, and you'll hear some terms in here that really apply either to a small garden plot, but more likely to a large farm. Keep your soil covered. And so that just means you want to keep something on it. It can be a cover crop. You can put down an organic mulch to control. All of this is going to control the soil temperature. It'll minimize evaporation, and it will also help eliminate or greatly reduce compaction from rain. And when you're getting 97 inches of precipitation a year, you get a lot of compaction. You also have the opportunity for erosion of your soil. You want to minimize disturbance. This is probably easier for the home gardener than it is for somebody working a few thousand acres. But going to no-till, no digging with the exception of to get a plant in the ground, and reducing or eliminating the use of pesticide, that will help the soil. That's all part of not disturbing it. And for annual plants, like we're going to be growing for vegetables or even in our landscape, you want to cut and leave the roots in the ground. And we'll talk about that in just a little bit. You also want to make sure that the soil structure is protected from compaction. Raised beds are really good for that because you have a very designated traffic area. In beds, you are going to want to put in a stepping stone or a piece of wood that you can stand on that will distribute your weight. And those are pretty easy steps to take. The other main thing for protecting the structure, remember we saw all the macropores and the micropores. The first to go with compacted soil are going to be your macropores. They get squished. There's no air space left. There's no water space left. And you're not going to have the good percolation of water through the soil. It will start puddling. So you want to make sure that you avoid compaction. Wet soil compacts pretty easily. Dry soil, not so much, but never work wet soil. And if you're not sure, I've taken soil and put a little in my hand several times and squeeze it, and drops of water come out. It's like squeezing a dish towel. I mean, it's amazing. Drip, drip, drip. That means the soil's way too wet to get out there and do anything in. You want to grow a variety of plants. You want to also look at keeping living roots over a long season as much as you can to provide food for the microbes. You want to intermix crops. We talked a little bit about microbes are fussy sometimes, and there's only a couple of plants as well as fungi that are going to be interested in working with that particular plant. So you want to try to get roots that go deep. You want to try intermixing cover crops. So if you have a space big enough to put in a cover crop, then you want to make it maybe a little bit more than just a legume or pea-type plant. You might want to put in some grasses too. Now, as with most of your cover crops, you're going to want to mow them down. Once the soil is firm, you're going to want to mow them down before they seed. And sometimes that's going to be a little more difficult if you already have a landscaped area. because you may not have a lot of space, but there are still things you can grow in there. And you may decide that you want to grow a plant that will set nitrogen as a cover crop. So there's some low growing plants, there's some perennial plants. And when you clean those up, you're going to want to go ahead and cut the root. You may or may not want to haul away the tops. You may want to use them as a mulch over the soil to protect from rain compaction and erosion. And we're kind of back to the amending the soil. Organic matter is really good. You grow a cover crop to protect the soil surface, and then later you work it in as an amendment into the soil. So organic matter can be green, or it can be the compost, which is in this place is going to be a soil amendment. Soil in the environment. Well, we talked about what happens if you've got 97 inches of precipitation a year. That kind of rain would wash out a fertilizer pretty quickly. The idea with fertilizer is to use the right amount at the right time. So what's the right time? Well, at this point, we've started our rainy season. So we've already passed the prime time for putting down fertilizers. And there's really two reasons not to fertilize at this time of year. If I put fertilizer out there on my rhododendrons, they're going to start putting on some new growth. That will be very, very susceptible to winter damage. And you really don't want that. It looks pretty ugly. We experienced that in the freeze in February. So what's the right amount? What you want to do is wait for the right time. The right time is when you start seeing many things start to sprout spring growth. And then you can put your fertilizer on. Otherwise, the fertilizer is probably going to leach out of the soil, go into runoff someplace, and it can damage streams and ponds. And this is typically going to be a phosphate, and that's the one that likes to take a pond, typically a confined area, and grow green, mossy looking stuff on the surface. Those tend to take the oxygen out of that water. Healthy soil will allow for infiltration of water, and it helps with the runoff. Remember those macropores, pardon me, those help conduct it. The micros will help hold it. And so we're talking here about a place for a lot of that water to go. Now, sometimes we still get enough water that the water starts running off. So you definitely don't want to get your fertilizer down too early. And we can be part of the revolution in agriculture. For a lot of the places, for agriculture in the big sense, it's regenerative farming. It's basically feeding the soil, and adopting the principles above are how we as individual gardeners can help with this revolution. Carbon sequestration is one of the things that those principles, healthy principles, also will help. It enhances carbon storage and improves soil. Well, the carbon storage comes from cutting your plants off rather than digging them up. I used to dig huge holes to get the squash roots and the tomato roots out of the ground. Over the winter, those are going to deteriorate, and they're not only going to have carbon that goes into the soil that can be stored, but they improve the soil, the water quality. And roots frequently are the ones that will make macro pores, or kind of tunnels for the water to go down. So if you leave those roots in, it decreases the nutrient loss, and it also decreases erosion. Plants take in the atmospheric carbon dioxide, and through photosynthesis, they store that in the plant tissue. When the plant dies, the carbon remains in the tissue and can be stored in the soil, specifically if you leave those old roots in. Carbon is also stored in the organic matter that we may use as an amendment to the soil. So here's a quick review. You were introduced to some terms describing soil that maybe you're not familiar with. Macropores, micropores. We may be familiar with the term, but not necessarily in the sense of soil. We have mineral particles, which we now know are the ones that are pretty interesting to us. We know the three major soil textures of sand, silt, and clay, and what each can do for us. Sand allows water to run through it pretty quickly. Silt is so-so, and clay is the one that has the nutrients, but we do have to watch that clay soil. It may need more organics added to it so that it can, again, have a little better drainage. A sedimentation test is something you could use at home, and hopefully this gives you an idea and you'll decide to go ahead and see what your soil is made of, how much sand it has versus how much silt. And if you're a person who has loamy soil, boy, you are in like flint. You don't have to do a lot, but you do still need to feed your soil. Soil microbes recycle dead cells and tissue. We talked about these little recyclers out there. And they form them into nutrients for various roots for their plants. The basics of pH we explored, and why testing is a good idea. And here I want to interject. Normally, our chapter would be doing soil testing, pH soil testing, 3 times a year. COVID has messed that up. You can look at our website and see if we have anything scheduled. Those are free, and I believe you can have a number of samples that you bring in. And you don't want to do a whole lot with your soil until you know you've got a good balanced pH out there. We learned how and why soil protection is needed and how we as gardeners can help reduce the carbon emissions. We don't dig in our soil as much as we may be used to. You only dig a hole that's big enough to get your plant in, and that's it. You try to make sure anything they're cutting down, you leave the roots in. Now, there are some things you have to be cautious of, and typically they're the weeds. So that's a good review. These are additional resources, and I believe these will be coming to you in an email after this session, and I don't know exactly when. Oregon State. The second one is Extension Service at Washington State University, and a lot of those are really good. Okay, then we also have some down here, Soil Science Society of America. They're just about soil. And I want to thank you for joining us today. And I leave you with a kind of pretty picture. These are called fall crocus, and they do have medicinal purposes and are actually used as medicine for gout. I don't know a lot about gout, but I know it's painful.
Well, thank you very much, Sherry. You may want to turn on the video so people can see you as we have a discussion on the topic. And if anybody has any questions, please put them in the your Q&A box. Well, as Sherry turns back on her screen, so we can see what she looks like when she answers the questions, why don't we start out with a question? You've talked about the importance of pH. What is the best way for me to get my soil pH tested? I heard you say the Clackamas chapter used to do free pH testing service, but because of COVID, that's no longer the case. So how do I get a test done and know what is my soil pH?
So the question was, if Clackamas County isn't doing a pH test, then what are my alternatives at this point? We have a link that will take you to a variety of laboratories outside of the Extension Service. These are personal private businesses. And you could take a sample there. If you do a sample, I would talk with them first, of course, and engage in what they do check. I don't know if any of them will do just the pH test. So you might have to get a sample that is done for a wide range of nutrients in your soil. And that's not a bad thing either. The pH will give you a basis to start from. The other thing that you can do, and they have become far more reliable more recently, is that you can get a test at a garden store. Many other places will carry them as well, and you can do your own pH testing.
Well, you mean buying a kit and a
I mean,
home testing kit?
yes, it's a home
Yeah.
testing kit. They used to be considered not very they weren't very accurate. And over the years, they have become more accurate, and testing by the Extension Services has said these are not a bad thing to use. And now, since we in the chapter really don't do pH, and who knows when it'll start back up, they would be an alternative out there.
Okay, so we're running short on time, so let's speed up a little bit.
Okay.
A few more questions. The website for where people can find testing information, I believe we have a handout on soil testing labs.
There's soil testing labs out there, and the other information, if you do it yourself, I'm not sure what they'll include. So you might want to look at the resource list or at our chapter, because there are handouts on interpreting or understanding your soil test.
Okay, let's do this. In the follow-up email after the webinar, we'll include the Oregon State publication link to soil testing labs, and also the link to the publication on how to interpret the test results. But for finding out our chapter's free soil pH testing service, just go to our website at cmastergardeners.org. Another question, if you use grass as a cover crop, is there a need to fully dig up the roots before you plant in the area, or can you just mow it down and it will not come back?
That's a really good question. Do I need to remove the roots if I use a grass for a cover crop? I think they're going to talk a little bit more about that in the clinic, but there are grass cover crops, and I would definitely make sure I got seed for one that was listed as a cover crop, because there are some very nasty rooted things out there that just go wild. So if you choose the right ones, my understanding is you can work them into the soil, but typically you want to leave them undisturbed and go ahead and plant through.
So continue on the cover crop topic, is it too late for, well, I know it's getting late for most of the cover crops, but I believe we can still plant fava bean?
Fava beans would be a nice legume that you could go ahead and put in. The only thing is the lateness here is going to be in regard more because of the cold weather that we may be coming up on. And I have had a crop of fava beans in that got frozen, and we had to start over because we wanted the beans for eating. But yes, it's getting a little late. I can't remember the span of time. Some of them I think need to be in by the end of September, middle of October. So right now we're right there at the wrong, we're getting close to the time when you don't want to plant them. You've got to give them enough time to sprout and grow a little bit to protect the soil.
Okay, so somebody has a question about timing for amending soil. Want to know if in the fall it's okay to amend with compost, with organic materials to improve clay.
I believe it would be better at this time of year because we're heading into the monsoon season, as it were, for this climate. And I think it would be better with less disturbance if you go ahead and work those amendments in the spring. And remember, if you put a cover crop out there, you're going to be mowing it down. And you may want to work that in as well in the spring. So you would be doing an amendment and turning it into the soil only one time instead of 2 times a year. So towards the spring would be a better time when the soil is not wet.
And maybe one option, Sherry, is go ahead and lay the organic material on top as a mulch over the fall time, because that may help with lessening compaction. And then in the spring, it's already there, and then mix it into the soil as an amendment.
Yes, that would be a good way to do it, and just kind of follow the same idea with any of the ones that you're using as a cover crop.
Okay, well, I'm sorry we have run out of time for question and answers, and we're going to conclude this segment